In this lesson, we are going to use what we've learned about situational, or about the law of sines and law of cosines to solve situational problems. Here's our first example. The world's tallest freestanding totem pole is located in Beacon Hill Park in Victoria, BC. While visiting the port, Manuel wanted to determine the height of the totem pole, so he drew a sketch and made some measurements. How can Manuel determine the height of the totem pole to the nearest meter? What you have to be able to determine is whether or not you are going to be using the law of sines or the law of cosines. The law of sines would be the easier of the two mathematically, but it depends on the information that you're given. If we want to determine the height of the totem pole, and if we were going to use the law of sines, we would need to know the angle that is opposite this side, and then we would have to know another set of opposites. So we know that this side is 42, so we would need to know its angle measure. Is there a way we can find out those two angle measures? And if so, then we could use the law of sines. In order to use the law of cosines, you would have to know two of the sides and the included angle, or all three sides. And as it sits right now, we only actually know one of the sides. So we are going to have to use the law of sines. So now we need to ask ourselves, how can we find these two angle measures? Well, the other information that we are given is we have this bottom triangle here. We know two of those angle measures. We know that this one is 5 and this one here is 40. So how can we find the third angle? Well, we know that 180 is the sum of all three. So we can subtract 180, subtract 40, subtract 5, and we know that it's 135. So this angle on this side of D is 135 degrees. How does that help us? Well, to find this angle right here, we have a straight line between those two angles, and straight lines always add up to 180. So 180 subtract 135 is 45 degrees. So this angle in here is 45 degrees, and that is opposite of angle H. And now, to find the other angle that we are looking for. Right here, we have a right angle. We know that part of this angle here is 5 degrees. So can we find this measure here? Yes, 90 subtract 5 would be 85 degrees. So now we have two of the three angles in the upper triangle. So 180 subtract 45 subtract 85 will give us the angle there at C. So we will have an angle here of 50 degrees. Now we have all of the information we need to use our sine law. So we have a side of 42 and its opposite angle is 50 degrees, so sine of 50. We are looking for angle or side H. We know its opposite angle is 45. When we now use our calculator, make sure it is in degree mode. Sine of 50 is 0.7660. Always go to at least 4 decimal places, if not more. Sine of 45 is 0.7071. From here, either solve it using linear equation rules or solve it by cross multiplication. So if we solve it by cross multiplication, we get 0.7660H equals 42 times 0.7071, 29.6982. We want to solve for H, so divide both sides by 0.7660. And you get the height is 38.77. It asked for you to go to the nearest meter, so the height is 39 meters. Next example. Brendan and Diana plan to climb the cliff at Dry Island, Buffalo Jump, Alberta. They need to know the height of the climb before they start. Brendan stands at point B as shown in the diagram. He uses a clinometer to determine angle ABC the angle of elevation to the top of the cliff. Then he estimates angle CBD, the angle between the base of the cliff himself and Diana, who is standing at point D. Diana estimates angle CDB, the angle between the base of the cliff herself and Brendan. Determine the height of the cliff to the nearest meter. So ultimately, what we are trying to find is side AC, the height of the cliff. Again, what you need to determine, to use the law of cosines, you would have to know at least 2 side measures. In this case, right now, we only know 1 side measure. So there's a good chance we're probably going to be looking at the sine law. Now, most of the information given comes from this bottom triangle here. Which side length there would assist us in finding the height in this upper triangle? Right here. If we knew this side length, we would then have 2 sides in that upper triangle, and we would be able to solve for the height. So what we want to do here is to find this side length. We need its opposite angle measure, which we have. The other side length that we know is right here. We need its angle measure. How can we find that? Well, we know 2 of the 3 angle measures. So we can start by finding angle BCD. And that's 180, subtract 50, subtract 60, which is 70 degrees. So 70 degrees is opposite the side that has 60 meters. So now we can solve. 60 meters is opposite the angle 70 degrees. We are looking for side length of CB. We'll call it M. You can choose any variable you want. And that is opposite the angle 50 degrees. So now we can solve for that side CB. So sine of 70 is 0.93969. Sine of 50 is 0.7660. Do our cross multiplication. 45.96 equals 0.93969 m. Divide by 0.93969. And we get 48.9 equals m. We're talking about nearest meters. So we will say that it is 49 meters. And that's the side length CB. So now, looking in that upper triangle, we know this side length. We could figure out its opposite angle. We are looking for this side length, and we know its opposite angle. So what we can do, this was a 90-degree angle. It was indicated in the diagram. This is 76. So angle A is going to be 180, subtract 90, subtract 76, which is 14. So we can now use the law of sines again to calculate the height of the cliff. We have 49 meters with side CB. The angle it is opposite is 14. We are looking for side AC, and its opposite angle is 76. Sine of 14, 0.2419. Sine of 76, 0.9703. Cross multiply. We get 47.5447 equals 0.2419x. Divide by 0.2419. And we get 196.5. Rounding to the nearest meter, 197 meters would be the height of the cliff. So in summary, to decide whether you need to use the sine law or the cosine law, consider the information given about the triangle and the measurement to be determined. So if you're given two sides and the angle opposite one of the sides, and you're determining another angle, you're probably going to use the sine law. If you have two angles and a side, and you're looking for another side, you will use the sine law. If you have two sides and a contained angle, and you are looking for another side, you will use the cosine law. And if you're given all three side measurements and you're looking for an angle, you will also use the cosine law.